So we already learned the power rule, where the shortcut to find the derivative, which is an equation of all the slopes of all the tangent lines, you can do that just by bringing the exponent in front and subtracting 1 from the exponent. Saves us a ton of time compared to using the definition. Okay? Then, what happens when you add a number in front? The rule doesn't change. But now when you bring that exponent out in front, that exponent will multiply. So for example, 4x to the 7. You're finding the derivative. The 7 would come out in front, hit that 4, turn into a 28. And you would just have 28x to the 6th. Again, way, way, way faster than using the definition, where you would have to actually expand x plus h to the power of 7. Okay, part B, same thing. That negative in front doesn't do anything. Just bring the 5 in front. Part C, we have some preliminary work to do. You've got to switch this first into a form which is a power. So I changed the radical to x to the 2/3. Then that x to the 2/3 is in your denominator. So you can use your negative exponent rule to move it to the top. And then you can apply your power rule for derivatives. And then depending on how you want to write your answer, you have all of those options. Next rule. Now all of these rules are technically just the power rule again. Okay? Now, the derivative of a constant is 0. There's a number of ways that we can think about this. If you graph the line y equals f of x equals 5, can you see that that's a horizontal line? Any tangent to any straight line is the exact same line. And so your slope of that line would be 0. Okay? You could also use the previous rule. Anytime you have a constant, which is just 5, you could, if you wanted to, write it as 5x to the 0, because x to the 0 would just be 1. But then if you apply your rule, where the 0 comes out in front and you subtract 1 from the exponent, well, what's 0 times 5? Times x to the minus 1? Well, it's all going to be 0 in the end anyways. So there's a number of ways you can think about a constant and find out that its derivative is 0. But the easiest way, what's going to happen is you're just going to remember, oh, it's a constant, derivative of 0. Okay. Now we're going to work backwards. There's the answer. There's the derivative. Could you find the original function? And did you get y equals x to the 5? Perfect. Next set of derivative rules. What happens when you're adding a bunch of functions together? So if you want to take the derivative of 2 functions that are added together, or 2 functions that are subtracted, or even more. And this should make you happy. You just have to find the derivative of each one separately. Life is easy. Okay? 3x to the 5 plus 2x to the 4th minus 7x squared plus x minus 5. You want to find the derivative of that. You can find the derivative of each part separately. So this will become 15x to the 4, 8x cubed, minus 14x plus 1, and then the constant would be 0. Okay? Just to give you a sense of how much time we are saving right now with these shortcuts. right? This is our definition of the derivative. And yes, you will still have to solve some questions. The derivative equals this, which would equal the limit of, you would have to plug in x plus h into this. So you would have 3x plus h to the 5 plus 2x plus h to the 4 minus 7x plus h squared plus x plus h minus 5. That whole thing would be your f of x plus h. And you would have to expand all of those. Then you would subtract. I'm just going to write f of x because that would just be writing that out again. And after you've expanded it and simplified it and canceled things out, you'd be able to factor out an h. Cancel out the h on the bottom and then apply the limit, and you're going to get this answer. Is there anybody that likes the definition better than the shortcut? That you would prefer in this question? Oh, I actually, I quite enjoy expanding x plus h to the power 5. In fact, that's what I do in my spare time. So I will always choose this method over the shortcut. Anybody in this class? No?
Did you ever figure out what to do with your boarding passes now?
No, I haven't yet. I asked Jen. And I'll get you to try C and D. I'll put the answers up in a bit. All right, let's see how you did on C. First of all, changing it, then applying your derivative. And you can leave it like that with negative exponents. Sometimes in textbooks, they will always write it with radicals or positive exponents in the end. So I have that, but you can do a check to see how you did. How did I get rid of the bottom number, like these here? So we have to use our negative exponent law to bring it up to be a power. So the x squared on the bottom becomes x to the minus 2. And then you can apply your power rule. If it's in your denominator, you will not be able to use your power rule. And finally in D, you'd have to multiply it out first so that it's in a form you can do the derivative, and then you could find the derivative. What's that? Go back to the one before? Yeah. Finally, another working backwards one. If you had this, what would it have been originally? Makes sense that you would have a 5x to the 4. And then any number by itself would have had just one x, because the 1 would come out in front, subtract 1 to the exponent to get that 0. So make your x's go away. And now, the reason that this question says find a function is because this isn't the only answer. Could you see that you could have had a plus 2 there, or a plus 3, or a plus 5? That would have been another answer. In fact, later on, when we do this working backwards more formally, you're going to find that you're going to say plus c, where c can be any real number. Because it could be anything there. If I wanted to list them all, I'd have to have that format. But this question didn't say list them all, it just said find a function. So you just had to find one. So if this is your opportunity, right, You're like, my favorite number is 37, and I feel like it's really underrepresented in math questions. If you get this question, this is your chance. You're like, yes, I can add 37 to my answer and enjoy it way more.